All right, let's get into it. So this is our definition of a prime number. Prime number is a number p which is bigger than one, and well, it's a natural number. It's bigger than one, and it satisfies the following condition: that whenever p divides a product of integers, it divides one of the integers in the product. And this isn't the definition you normally see when you see prime, or what I guess the average person might normally think about when you think about prime. Normally, you think about a prime number as a number that you sort of can't break apart under multiplication. This is slightly different, and we'll see that it's actually equivalent. And the thing that makes this definition a better definition is that it's a more helpful definition for more abstract algebraic structures, namely, when we think about how primes generalize later. And it's therefore sort of helpful to try to grapple with this definition now, just to set us up for later. And the negation of being prime is being composite. So if you are a number, a natural number bigger than one, you're composite if you're not prime. And you're not prime if you can find a product that you divide such that you don't divide either of the terms in the product. Okay, so the first few primes you see are here. It's kind of hard with this definition to see that they're prime, but we could try, for example, with 2. 2 is prime because if 2 divides a product of the two integers, well, 2 is even, so it's saying this product is even. But the only way to multiply two integers and get an even integer is if one of them is even, at least one of them at least. So that would tell you that p divides the even. And then, you can try to think about how you might prove these other guys are prime with this definition. The number 1 is not prime. This is a common mistake. The number 1 is not prime, well, because it's not bigger than 1, and that's a cop-out answer. The real answer is that it's not useful to allow 1 to be a prime number, and actually it's a hindrance when we generalize the notion of primes to other algebraic structures. So we'll see at least one example in this section on why it's not useful to allow 1 to be prime. 1 is a special type of number in the integers, and we'll get to that when we get to that. And here are, the first so many composite numbers as well.